Today we will talk about immunity. First, we'll talk about different types of immunity present in your body. Then we'll talk about the mechanism of action, how different types of immunity uh, protects your body, how they work to protect your body. Uh, One way to protect your body is producing antibodies. So, antibodies are the proteins that fight against the antigens. So, antibodies are produced in your body in one type of immunity, and that fight against the antigens. We'll talk about the antibody, different types of antibodies, and properties of antibodies. Uh, there is another type of immunity that is called the cell-mediated immunity, which is actually different than antibody-mediated immunity. In this case, the cells do phagocytosis, engulf the microorganisms or antigens without producing antibodies. Okay, they kill the microorganisms. So, two ways the cells can, or lymphocytes can, destroy the microorganisms or antigens. One is by engulfing, that is called phagocytosis, and another is by producing antibodies. Then antibodies will go to the target cell or antigen and destroy it. So we'll talk about both cell-mediated and humoral immunity. Humoral means fluid, and that is antibody-mediated immunity. So humoral is another name of antibody-mediated immunity. Then both types are divided into active and passive. So we'll talk about that. First, what is immunity? Immunity is the ability of your body to fight against the antigens. So human body, you all know that human body has the ability to fight against the antigens and can destroy them, and that ability is the immunity, defensive function of the body. Now, immunity is divided into two types, innate and adaptive. Innate immunity is the immunity everybody gets by birth. So, when your body is formed inside the mother's uterus, your body, everybody gets that protection. What is that? Example, skin, right? Skin covers the body, whole body, and protects your internal structures. And everybody gets skin. Make sense? So that is innate. Another example of innate is, the mucous membrane in the respiratory tract, the lining of your GI tract, the mucous lining of GI tract, gastrointestinal tract, respiratory tract has innermost layer, right? Lining, epithelial lining, and that is also present in everybody's body. So those structures protect us by forming a layer or barrier, and we all have that. So those are innate immunity. Adaptive immunity, which is also called acquired immunity. So adaptive has another name, which is called acquired immunity. This immunity our body develops or grows when you get any antigen. So when any antigen enters into your body produces that immunity adaptive or acquired in response to that. Make sense? So you don't get it by birth. When you get it, when antigen enters into your body produces it. Is it clear? So one type innate, you get, everybody gets that. Like a skin, mucous membrane, right? In the respiratory tract, in the GI tract, gastrointestinal tract, that is innate. The one that is produced in response to an antigen, when antigen enters into our body, that is called acquired or adaptive immunity. Okay? Like memory cells? We'll talk about that. Okay? Yeah, memory cell is a part of adaptive. So, like you got swine flu virus, right? Your body will produce immunity against that. Make sense? Will fight against it. So only you have that immunity. Make sense? If I didn't get that, my body did not produce that immunity. Make sense? So that is adaptive or acquired. Now, there are 3 lines of defense in your body. First line of defense, second line of defense, and third line of defense. First and second lines are given by innate immunity. Third line of defense is given by the adaptive or acquired immunity. So very simple. You see, if any antigen tries to enter into your body, who will try to stop it first? Skin, right? Or if the antigens try to enter through air, enter into your respiratory tract, right? Through air, and your mucous membrane in the respiratory tract will try to stop it from entering into the body. Is it clear? So those belong to first line of defense, and you know that those are the parts of innate immunity. So first line of defense is external body membranes like skin and mucous membrane. Skin covers the body, mucous membrane covers the respiratory tract and GI tract, right? So if it enters into your GI tract through food, the food you eat, then who will try to stop first? The mucous membrane of GI tract. So those are first line of defense. Second line of defense is antimicrobial agents or proteins present in your tissue. Phagocytic cells, you know that macrophages, right? In the tissue, those are phagocytic cells. They can do phagocytosis. And other phagocytic cells, for example, dendritic cells, you can write it down, another type of cells present in the tissue, dendritic cells, they also do phagocytosis. So, proteins in the tissue, for example, tissue enzymes, protein in the tissue or tissue enzymes, then macrophages or dendritic cells. All those are present in the tissue. So now you see here, look at me. If somehow that antigen can cross the skin, pass through the skin, will enter where? Into the tissue under the skin, right? So the second line of defense will then try to kill that. Tissue enzymes or proteins, phagocytic cells, macrophages or dendritic cells. Make sense? So if first fails, then second line of defense will try to stop that or kill that. Is it clear? Then, so both are innate because you get all these skin, mucous membrane, tissue macrophages, right? Tissue proteins, everybody gets it by birth when our body is formed. So first and second lines are given by innate immunity or defense system. Then third line of defense is given by adaptive or acquired immunity. If the antigen enters into your lymphatic system, you must remember from the interstitial fluid the fluid enters into the lymphatic capillaries and becomes the lymph, that fluid. So if the antigen enters into the lymphatic system, then the lymphatic system will produce adaptive immunity. In response to that antigen, your immune system, lymphatic system, will produce immunity. That is the third line of defense, which is adaptive. Only your body will produce that immunity when it gets antigen. Okay, now adaptive for acquired immunity is given by lymphocytes, and you already know there are two types of lymphocytes: T lymphocytes and B lymphocytes, also called T cells and B cells. Both give adaptive immunity or acquired immunity, and you know that they work differently. After the lymphocytes are formed, some lymphocytes go to thymus and get their training there, I mentioned in last class, and they become T lymphocytes or T cells. Some of them get their maturity or training inside the bone marrow, and they become B lymphocytes, and they learn how to fight in different ways. They learn, they are trained differently. T lymphocytes do what? Phagocytosis. Okay, T lymphocytes learn to do phagocytosis, and now B lymphocytes learn to produce antibodies. Okay, you see they fight not same way. T lymphocytes do phagocytosis and B lymphocytes produce antibodies and secrete, and that antibodies that destroy the antigens. Make sense? Okay. Now, differences between innate and adaptive. Now, if I ask you, what are the differences between the innate and adaptive immunity? You can say that this one we get when our body is formed, right? Skin, mucous membrane, we get by birth. Adaptive develops once the antigen enters into your body. It could be at age 10 or 15 or 20, right? When any antigen enters into your body produces immunity against that. So that is adaptive. So at any time, once the antigen enters, at any time it can be produced in your body in response to that antigen. Innate immunity provides which line of defense? First and second. First and second lines of defense. Okay. Now, adaptive immunity provides third line of defense. The innate immunity, since it is already present, right? Skin is already present in your body, will work immediately. If any antigen tries to enter, it will immediately try to stop it. Makes sense? Because your body has that. So, immediately. But adaptive immunity, as I told you, once antigens enter into your body, then your body develops that, right? So it grows slowly. Make sense? Not immediately, it grows or develops slowly. So immediately action or response, this one slow, grows slowly in the body. Once antigens enter, then body starts to grow back. Innate immunity does not have any memory. Does your skin has any memory? What do you think? Skin doesn't have any memory, right? Because your skin cannot tell that this antigen came 5 years ago. Your skin doesn't have any way to tell that, right? It is like a barrier. It will try to stop everything. Okay? So it doesn't keep any information about previous invasion, right? So skin or innate immunity has no memory in it. But adaptive immunity, as you are asking, memory cells, right? So some lymphocytes, T or B lymphocytes, they can keep the information, okay, about previous invasion. That yes, 5 years ago this antigen, entered into your body before. Make sense? So memory can be stored in adaptive immunity. So adaptive immunity or immune system has memory. The action of innate immunity is not specific. That means non-specific. Very simple. Your skin will not tell that I will only stop this or I will only stop that, right? Because the skin will try to stop everything. Will try to stop anything. Not selective. Make sense? But adaptive immunity is highly specific. Only if swine virus enters into your body will produce antibody or immunity against only that particular antigen, right? If swine virus enters into your body will not produce antibody against rabies virus. Make sense? It will produce against that specific antigen, right? When rabies virus will enter, it will produce against that one, right? So adaptive is highly specific, but skin or mucous membrane will try to stop anything. So non-specific, but adaptive is highly specific. Highly specific. Okay. So these are few differences between the innate and adaptive immunity. We have talked about this when we talked about the white blood cells, so we don't need that. So here you see adaptive immune response is specific, highly specific, that I have mentioned, has memory, is systemic. Systemic means your lymph, that fluid circulates throughout the body. Throughout the body, the lymph fluid circulates. That means it goes everywhere. That is systemic. But skin is not, it is just covering the body. But inside the body, you don't have that. So we can say that it is not systemic. Innate is not systemic, but adaptive is systemic. It goes everywhere. The lymph fluid, T cells, B cells go everywhere in your body. Adaptive has two arms that I have already mentioned, B cell and T cell mediated adaptive immunity. B cell mediated is also called humoral because B cells produce antibodies, right? And antibodies are fluid, circulates in the fluid. And humoral, the term humoral means fluid. Anybody remember inside the eyeball you have aqueous humor, vitreous humor? Do you remember? Humor means fluid. Okay, so antibodies circulate in the fluid. That's why it is called humoral antibody mediated. T cell mediated immunity is also known as cellular because the T cells engulf the antigens directly. They get attached to the antigens directly and engulf them. Otherwise, they won't be able to engulf, right? To engulf something, they need to get attached to the antigens directly. So that's why they are called cellular or cell mediated immunity. So humoral is B cell mediated antibody and cellular T cell mediated and do by phagocytosis. If you see someone is coming towards you, want to fight with you or destroy you or harm you, then you can fight differently. If you see the person is very small and you are very big, right? You let him come. Okay, come close to me. I'll destroy you, right? And we'll grab him. So that is T cell mediated, right? Engulfing, right? Getting attached directly. But if you see that person has a gun, right? Then you won't let him come close to you, right? So you'll probably shoot something towards him from far, right? So that is B cell mediated. B cell does what? Produce and release antibodies. Make sense? And then antibodies go to the enemy and destroy. Make sense? So two different ways. You already know B cells go to the bone marrow and get their maturation there. T cells go to thymus and get their maturation there. Now, let me mention different types of T cells. T cells could be different types. Okay, one is called cytotoxic T cells. Another type is called helper T cells, and then suppressor T cells and memory T cells. Okay, so these are different types of T cells and they work differently. Cytotoxic is also known as natural killer cells. Natural killer or NK cells. Cytotoxic or natural killer cells. This is one type of T cell that destroy the infected cells in your body, tumor cells or cancer cells. So infected cells, make sense? If any cells got infected by virus or bacteria, infected cells, cancer cells, tumor cells, those are directly destroyed by the cytotoxic T cells. Cyto means cell, toxic means harm. So these cells can harm and destroy those abnormal cells. Very helpful, right? Helper T cells. Helper T cells does what? Stimulate the other T cells and enhance their functions. So this is the helper T cell. What happens? This is microorganism. Okay, antigen, and there is a type of cell that is called antigen presenting cell. Antigen presenting cell. what happens, antigens are taken by the antigen presenting cells. So antigen gets attached to this cell, and then this cell comes to the helper T cells and stimulates the helper T cells to release proteins. Okay, so helper T cells will release the proteins called cytokines, and this protein will stimulate the T cells as well as the B cells, other T cells and B cells. So when the T cells, other T cells and B cells will be stimulated, then they will destroy the antigens more, because their function is destroying the antigens. Okay, so that's how the helper T cells work. Okay, but to activate the helper T cells, antigen presenting cells must bind with the antigen and come to stimulate the helper T cell or activate the helper T cell. Okay, so once the helper T cell is activated, it will release the chemicals, cytokines, and that will stimulate the other T cells as well as the T cells. So they will destroy the microorganisms. Okay, so that's how the helper T cells work. Suppressor T cells. This is very interesting. You know that sometimes your immune system works too much than that you need. Make sense? So becomes hyperactive or overactive, hypersensitive. Okay? So in that case, what should be done? They should be suppressed. The activities of T cells and B cells should be suppressed. So suppressor T cells are also called regulatory T cells. They will regulate the immune function of your body. If your immune system works too much, then suppressor T cells will inhibit the cells. Just know that suppressor T cells inhibit the helper T cell macrophages, so those cells, also B cells. So those three types of cells are inhibited by suppressor T cell. So that will bring the immune function back to normal. You know, autoimmune disease, have you heard that? Autoimmune disease, if your immune system works too much, it starts to destroy your healthy cells of your body. Make sense? Because working, they're supposed to do what? Destroy the cancer cell, abnormal cells, right? Infected cell. But sometimes if your immune system becomes hyperactive, sometimes they can destroy the healthy cells, like the cells of your joint that causes rheumatoid arthritis, you know that, right? Autoimmune disease. So that should not happen, but that happens sometimes. So in that case, the suppressor T cells should do what? Work more, right? To inhibit the immune. And that's why your immune system is remaining under control. Yes.
Do they just inhibit the effects of histamine, or do they?
Inhibits the inflammation. Okay, so suppressor. Now, memory T cells. Memory T cells, as I have mentioned, that some cells in your adaptive immune system can keep the record of previous invasion. Make sense? Like your body got an antigen before, some T cells will keep record of that. So when second time that same type of antigen will try to invade into your body, your immune system will quickly respond because your immune system memory cells has the record of that, right? Antigen. So it knows that what kind of antigen is that. So your immune system will work much faster. And that's why you all know that we say that if you got certain, virus or microorganism before, second time the chance of getting sick is less, right? Because your body has record of that previous invasion. So suppressor T cell can recognize the antigens if your body got same type of antigen previously. So that is the function of memory cells. Now B cells could be memory B cells, and some B cells are converted to plasma cells. I mentioned that in last class. Plasma cells, and plasma cells can produce plenty of antibodies. Okay, so memory B cells work same as memory T cells, keep the record of previous invasion, and plasma cells can produce huge amount of antibodies. B cells directly produce antibodies, but once the B cells are converted to plasma cells, they produce more antibodies. Okay, so that's the B cell. So those are different types of T and B lymphocytes. Here they have shown that once the lymphocytes are produced from the stem cells in the bone marrow, some lymphocytes go to thymus and get matured there and enter into the lymphatic system. You see the green color inside the circle, that's the lymphatic system, lymph node. So, and some lymphocytes get matured in the bone marrow and become B lymphocytes, and both T and B lymphocytes enter into the lymphatic system and stay inside the lymph organs, lymph nodes, and are housed there. When the fluid brings the antigens, they destroy them. Okay. Okay. Now the humoral immunity. Or antibody mediated immunity. Let me show you from the beginning so it will be easy for you to follow. Immunity could be two types, you already know, right? Could be adaptive and innate. Right? You know that. Which one will get by birth? Everybody. This one, right? And this one provides which lines of defense? First and second. So this is first line and second line of defense. Adaptive is produced once you get antigen, and that is third line of defense. Then adaptive has two branches, you already know, cellular, that is T cell mediated, engulfed, right? And humoral, that is antibody mediated, that means B cell. Okay? Antibody mediated. This is by phagocytosis. Now humoral could be divided into two. Active humoral and passive humoral. So active humoral and passive humoral. Humoral is given by antibodies. Is it clear to everybody? Humoral is given by who? Antibodies. Now, humoral could be, or antibody mediated could be active or passive. Now let me give you an example. If your body gets an antigen from outside, your body will produce antibodies against it. Is it clear? Your body will produce antibody against that antigen. Is it clear? So your body is actively producing that antibody against the antigen. That is active humoral immunity. Passive. Now, for example, you already got a virus and that virus has spread everywhere in the body, and your body, look at me, your body is not able to fight against that antigen because it is already, huge amount of antigen has been entered. In that case, what you will do, you will get antibody from outside and inject directly. Antibody you are injecting because your body cannot produce enough antibody against that. So that is passive because your body is not producing, you are getting from outside. Is it clear? Getting from
Like
antibiotics. Antibodies you are getting from outside. So now let me make it more simple. Just know that in case of active, who enters? Antigens only enters, your body produces antibody against it. Make sense? In case of passive, you are getting what from outside to fight against that antigen has already entered? Processed antibodies. Is it clear? Because your body is not producing enough antibody. Make sense? So you are getting from outside. So that will be easy for you to understand. In case of active, only antigen is entering, your body is producing antibody against it. Clear? In case of passive, your body is not producing enough, so what you have to get from outside? Processed antibody, right? From another person or another animal, right? Or plants, you produce antibody and get the antibody directly because your body is not producing enough. Okay. So now you tell me, if you all of you get vaccine, right? Shot vaccine. Vaccine is actually antigen. Vaccine is what? Antigen. And we actually inject the antigen into the body as vaccine. And that antigen produces antibody or immunity against that. Is it clear? So that is active or passive? Active, right? Because you are injecting what? Antigen. That's why I asked you. You are injecting not antibody. You are injecting what? Antigen. Like microorganisms. You are injecting. Okay? So your body is producing antibody against that, right? Two ways your body gets antigen. One is natural. Antigens are everywhere floating in the air, right? And you are getting that antigen from outside. Is it clear? Like bacteria, virus you are getting from nature. That is natural, active. That is entering into your body and your body is producing immunity. So that is natural, active. Now, vaccine is also antigen, but we are making that, right, in the lab. We are manufacturing it, right, that antigen in the lab and injecting into the body. So that is natural or artificial? Artificial. Is it clear? In both cases, who is entering? Antigens. One is from the nature, another you are injecting, right, into the body. So in both cases, antigens are entering and triggering the production of antibodies in your body. So both are active. Now we can say active could be natural and artificial. Artificial. Okay. Artificial is the vaccine. So vaccine is an artificial active type immunity producer. Okay. Now remember, vaccine we inject into the body. I said vaccine is antigens, right? Those antigens we inject into the body in a harmless way. That means we make sure, right, before we inject the antigens into the body, that in the lab we test, right? When we manufacture, we make sure that when we inject that antigen, that cannot harm the body. Is it clear? Otherwise they will spread quickly, right, and will cause disease. We don't want. So we say highly attenuated antigen. That means we break their legs and hands, right? Break them or tie them and make sure they can trigger the immune response but cannot cause harm to the body. Is it clear? They're strong enough to produce immunity into your body, but they cannot spread and cause harm. Is it clear? So we need to make sure that. So highly inactivated or attenuated antigens we inject into the body, but they must be able to stimulate the body to produce antibody. Okay, so that is active, natural, artificial. Passive. In case of passive, antibodies enter into your body because your body cannot produce enough antibody. In that case, we will do what? Give antibodies from outside. Is it clear? Now you tell me, baby, infant gets mother's milk, right? And mother's milk has specific antibodies. Those are needed for the baby, okay? So antibodies are entering into the baby, right? The baby's body. So it is passive because antibodies are entering, right? Not antigens, antibodies. And it is natural or artificial? Natural, right? Mother's milk is natural. Natural, passive. Baby gets milk from the mother and antibodies enter into the baby's body. Now let me give you an example of passive artificial. If someone gets AIDS virus, you know AIDS virus do what? You know that. AIDS virus attack the lymphatic system, immune system, right? And destroys the immune system. I believe you have heard that. AIDS virus destroy what? The immune function of the body, right? Immune system. So the patient's body cannot produce antibody. Is it clear? Because your immune system is destroyed, non-functioning. So in that case, if you get infection, the chance of getting infection is high, right? Because your immune system is not working. Is it clear? So in that case, if the patient gets infected, you will do what? You will inject antibodies, plenty of antibodies from outside. Is it clear? As medicine or treatment. So that is artificial because you will buy from the drugstore, right? And will inject that into the body because patient's body immune system is not working, cannot produce antibody. You will get antibody from outside and inject that. So that is what the patient is getting antibodies. That means it is passive but artificial because we manufacture that and inject that. Okay, it's not natural. So it could be artificial. Okay. So I gave you the example of all four types: active natural, active artificial, passive natural, passive artificial. Okay. Okay. So easiest way to remember is we are getting antigens. That is what? Active. Your body is producing antibody against it. We are receiving antibodies as treatment or to increase the immune function of your body. From outside we are getting antibodies. That is passive. antibodies are immunoglobulins. You must remember when we talked about the blood, different types of plasma proteins, albumins, globulins, fibrinogens, right? And at that time, you have learned that globulins provide immunity. So, what kind of globulins provide immunity? Immunoglobulins. The name is very simple because globulins that provide immunity. And these globulins are also called gamma globulins, okay, of the blood, and mainly secreted by the plasma cells. Few minutes ago I showed you some B lymphocytes are converted to plasma cells, and plasma cells produce plenty of antibodies. So mostly secreted by the plasma cells. Antibodies must be able to bind with the antigens. Otherwise, antibodies will not be able to function. So, antibodies must bind with the antigens to form antigen antibody complex. Antigen antibody complex must be formed. That means they must bind to each other. Now, if you see the structure, microscopic structure of an antibody, antibodies look like Y or T. So the shape of antibody is Y or T shape. Now, there are 4 polypeptide chains, and those polypeptide chains are linked together at different locations. So let me see here. This is the structure of an antibody. You see Y shaped and 4 polypeptide chains. 2 chains are long, you see, and 2 are short. So heavy chains and light chains. You see this one is long, this is another long. So these 2 are called heavy chains. And shorter chains are called light chains. So 2 heavy and 2 light chains are present in the antibody. Now, so here let me draw these 2 are heavy chains, and then these 2 are light. Now, both heavy and light chains have 2 parts in each. The outer part is called variable part, and inner part is called fixed part. So this is variable, that means not fixed, and this is constant or fixed. Okay, so all those 4 polypeptide chains have variable or non-fixed part and constant and fixed part. Same thing here. Right? So this is variable part, fixed part, fixed part. Okay. Now, disulfide bonds connect the chains. You see those yellow structures, those are di means 2 sulfide, disulfide bonds connect the chains to each other. Now, why the antibody has variable and constant part? Just know that variable part binds with the antigen. So, for example, this antibody and this is the antigen, and antigen has harmful sites. For example, this antigen not everywhere is harmful. This part is harmful. This part causes harm. This part causes harm. This is another harmful site. Like when you fight, you use the legs and arms, right? Sometimes you bite. So those are the harmful sites for your enemy. Make sense? For your enemy, those are the harmful sites of your body. So antigens also have harmful sites, and those must be blocked, tied. So what happens? You see, these are the variable parts, and the antibody goes to the antigen and just like this. This is one antibody. This is another antibody. This is another antibody. This is another antibody, right? So you see the variable part is getting attached to the antigen and blocking the harmful site. 4 antibodies here, and the variable part is masking or blocking the harmful sites of antigens. So this antigen is now harmless, cannot cause harm. So that's how, and this is called antigen-antibody complex, by the way. So you see, antibodies must be able to bind with the antigen to inactivate it, and that is the complex. So now, interestingly, having variable part increases the efficiency of antibody function. How? You know, in your car, you keep a toolbox, right? You keep toolbox, and toolbox has one, you'll see one shaft, right? One, how to say, the part handle or shaft part, and multiple, the part that different sizes, and you can just keep the same shaft, right, or handle part, change the end part only, right, to unscrew based on the size of the screw that you will unscrew. So you can change that part, only the end part, right, and use that. So it is like that. Just think that this part is fixed part, right? So now if this antibody wants to work against a different type of antigen, what you will do, it will just change the variable part, only this part, and by changing that, it can inactivate the another type of antigen. So that is the efficient way to work, right? Now if you have the shaft part for all the variable part, then you will need a lot of antibodies. But in this case, only by changing the variable part, this antibody can work on different antibodies. So just know that the antibodies can change the variable part to work on a different type of antigens, and that is efficient way to inactivate the antigens. So that's how the antibodies work. Now, antibodies can work in 3 different mechanisms. What are those mechanisms? The commonly used mechanisms are neutralization, agglutination, and precipitation. So those are the common mechanisms how antibodies fight against the antigens or inactivate or kill the antigens by neutralizing, by agglutination, and precipitation. Here you see antibodies bind with the antigens to form, see the top part, antigen antibody complex that I have mentioned, right? So the red structures, those are antigens, and blue Y-shaped antibody. They together form the complex. And then the complex can work three ways: neutralization, agglutination, precipitation. Now, neutralization is what I showed you here. You remember I told you there are harmful sites or areas and antibodies block them, right? Antibodies block them, so mask them so they are not harmful anymore. That is the first one, neutralization. You see a number of antibodies got attached to one antigen. Agglutination. Here you see the red blood cells are antigens. When the red blood cells are antigens, you already know on the surface of red blood cell there are different antigens that determine the blood type. You already know that, right? A antigen, B antigen, D antigen. Those decides the blood type. But those are what? Antigens. You must remember that, right? Antigens on the surface of red blood cells. If mismatched blood transfusion is done, like your blood type is A, you get B, right? So in that case, that B antigens of your donor will be considered as enemy. So your blood will destroy the red blood cell. So how? By agglutination, clumping. Another way you can say clumping. You see multiple antigens or red blood cells are attached to each other by a number of antibodies. So these red blood cells will eventually be destroyed. The cell membranes will be destroyed. Precipitation. This is the way antibodies get attached to a number of antigens and make the whole structure heavy, because antigens are all chained together. Like if you chain your enemies together by rope, a similar way, or chain, the antigens will not be able to move from there. So that complex will stay somewhere, will not be able to freely move in your body. So by restricting the movement of antigens, antibody can deactivate them. Okay, so that is precipitation. Now another way that antigens are destroyed, that is called by releasing complements, or you can say activating complements. Complements are present in your body by activating complements. The complements are activated by a cascade of reactions, chain reaction. Like one complement is activated, then that will activate the next one, that will activate the other one. So a number of reactions occur during the activation of complements, and just know that finally activated complement will destroy the antigens. How? The complements can do three things. One is by lysis, by phagocytosis, and by increasing inflammation. So these are three ways complements work: by increasing inflammation, by lysis, or rupturing the cell, and by enhancing phagocytosis. Okay, so these are three ways. Here you see the complement in the right side. You see this picture. The complement opens the pores on the cell membrane. So you see that complement is going to the cell membrane and opening the pores on the cell membrane. So this is the cell. Cell means in this case, remember, this is either cancer cell or infected cell or a virus or bacteria. Okay? Virus or bacteria or abnormal cells. Now, you know that all cell membranes have pores, channels. You already know that. So these channels, so when complement goes there, complements do what? Make the channels bigger. Open the channels more. So fluid will easily enter into the antigen, bacteria or virus or abnormal cell, and will make the cell bigger, and at one point the cell will rupture. So by opening the pores or holes on the cell membrane, complements can destroy the antigen. That is lysis. Okay. Some complements do what? Stimulate the phagocytic cells. So phagocytic cells will engulf more. So that is by stimulating phagocytosis or phagocytic cell. You see, macrophages can be stimulated by complement and engulf the antigens more. Inflammation. Inflammation is actually, I told you in last class that although we think inflammation, we feel pain, in the area, but that is good for you, right? Because when inflammation occurs somewhere, that means more blood flows there. More white blood cells are going there. Make sense? And white blood cells do what? Destroy the antigens. We all know that, right? So, inflammation increases the blood flow, increases the movement of white blood cells to the site of inflammation, and those white blood cells then can engulf or destroy the antigens more. So, some complements increases the inflammation, and that way you see the white blood cells in the middle portion, middle box, inflammation, the white blood cells will go there and will destroy the microorganisms. Okay, so that's how the complements work. One more thing you need to know that is also very important. Complements, as I have mentioned, another is called interleukins. Interleukins. Interleukins are signal proteins. These signal proteins are secreted from the infected cells, for example, viral infected cells. Okay. So, infected cells secrete the interleukins. For example, this is your tissue. These are the cells in the tissue, and these few cells got infected. So these are infected cells, and these are healthy cells, not yet infected. So what these infected cells do? Infected cells secrete interleukins. Okay, and the interleukins, the signal proteins, then will go to the healthy cells. We take the signal to the healthy cells, nearby healthy cells, and will tell these healthy cells to release the chemical that will stop the multiplication of this virus. So stop the proliferation or multiplication of what? The virus. So I'm repeating again, infected cells release interleukins, signal proteins. Interleukins will go to the nearby healthy cells, then healthy cells will do what? Will secrete the chemical that will stop the multiplication of the virus. So virus will not be able to spread. So that's how interleukins work. Very helpful signal protein. Okay, make sense? So yes.
Will the MHC protein be able to transform?
Which one?
MHC protein?
Uh, uh, that is histocompatibility complex. Yeah, you can know that